Hi, here is exam 2B, question number 7, the last question for the exam, looking through the synthesis questions and how to solve these synthesis questions. The question asks you, show how you would most effectively accomplish the following synthesis. Show all isolated intermediate products and reagents over the arrows. More than one step may be required. And so here, when I'm comparing this, I'm looking through here and trying to figure out, okay, what has been changed, what has been added. So when I compare this group compared to here, this motif, this isopropyl group connected to these two carbons is mirrored here. So those carbons have not changed. So what I need to do is, at this location, I need to add an oxygen. Here, I need to add an oxygen that has an ethyl group on it at this spot. So I need to think about how I would go about doing this. Well, first of all, I'm at a spot where I'm adding 2 oxygens. So the options I have to adding 2 oxygens is using osmium tetroxide followed with H2O2, and that would get me cis oxygen, but that would definitely get me 2 OHs, and I don't know how to make an OH into an OET. That's not something I know how to do yet, so this gets me stuck in a spot. This also does it in a way that's cis, but that's irrelevant in this particular spot. So that's not going to help me to get anywhere. The only other way I know how to add 2 oxygens is to first add MCPBA. So that would get me to this intermediate here. And then I get to the spot. Sorry, I'm kind of at an odd angle here for you. So then I get to here. And then if I want this to be my nucleophile, because I could have that be, I need to have my nucleophile add to this carbon. This is my less substituted carbon, so I want anti-Markovnikov ring opening of an epoxide. So to do that, I would use sodium OET. I need it to be strongly basic conditions, so it can't be alcohol here. It has to be the alkoxide. And then follow that up with dilute HCl to neutralize that reaction. That would then give me an OH here and an OET at that location. Then I can simply take this and add any sort of oxidizing conditions, KMNO4, Jones reagent, which is CR03, an acid, or NaCr2O7, an acid and water. I'm going to choose to write down KMNO4 because that's the easier set of reactions. So that's how you would solve that one. The other synthesis question has a lot to do with the stereochemistry of what's present. And I'll be honest, when I first made the key, I wrote down the wrong answer to this one. So when I think about this one, same idea, I have to say, all right, I have 1, 2, 3, 4, 5, 6 carbons, and 1, 2, 3, 4, 5, 6 carbons. First thing I would do is notice how the functionality that I have to work with is on the right side of the molecule over here, but the left side is where I've added things over there. So you could flip either one of these around or realize that that doesn't matter which side I'm putting it on there. So this carbon and this carbon are the same, and this carbon and this carbon is the same. What I have now added is I have this, and I need to add H and H, and then I need to add Br and Br. Or you can think of it as adding H and Br and H and Br. But I need to add it in a way, I'm told very specifically that these two have to have this stereochemistry. So it's not a good idea to add H and Br and H and Br of one Markovnikov and the other anti-Markovnikov. The better choice is to add it in a way that would get me to this stereochemistry. Now, when I think backwards, I'm actually going to take this one and work from this side. When I add Br2, because that's how I add 2 bromines at a time, that happens in a trans method. So for me to get this stereocenter, or stereochemistry, what I actually want to get is my bromine here, rotate this group around 120 degrees. This shows me that bromines in that trans stereocenter. So these two drawings are the same compound, just rotated around. But that shows how those bromines are trans, and also then shows me how I have to get to this 1, 2, 3, 4, 5, 6 carbons, start with this double bond. So I need to find a way to get to this to form this double bond, because when I add bromine to this, it adds trans, and I need to get this net, if you follow that. Well, I do know a way to do that. I can add this, and I add H2 across here. I don't want to add H2 in a trans fashion. I want to add it in a cis fashion. You can't just add H2 in palladium, because that would reduce all of my double bonds and all the way down to a single bond. And so I want to use H2 in Lindlar's catalyst or Ni2b, whichever one you want to think about there. And that would accomplish that stereochemistry, giving me that specific stereoisomer as requested.